Welcome back to the very cool development of my handheld game system. Before I say anything else, we've got a lot to cover today, so let's just get straight into the first part. So what's the very first thing a console needs if you want to use it? I'm sorry, but loading a game is actually the correct option, as without it you've just got yourself a paperweight with a battery inside. Loading a cartridge is actually way simpler than most people would think. Since the OS is just going to be built on top of a very stripped down version of the Linux kernel, I can load the cartridge code as a simple dynamic library, or as smart people call them, SO files, which, as you can see right here, does exactly what it's supposed to. Wait, that's on Windows. As you can see, it works great, and I'll deal with the Windows stuff later, but loading cartridges isn't really enough now, is it? They actually need to do something, like interacting with... When it comes to rendering anything, the core of it all is the pixel. As you can see, pixels are what make up the entirety of all our screens, whether it's from your computer or your PlayStation 19 or whatever they're up to nowadays. Implementing a pixel drawing system is really easy, since the current version of the screen output I'm using is just a giant list of pixels, which is also called a frame buffer. You can just find the pixel you want to edit by using a simple math formula. All you've got to do is you get the maximum width of the screen, and then you multiply it by the y-coordinate of the pixel, and then you add the x-coordinate of the pixel onto that, and that gives you the number in the list of where the pixel is located, and then you just update that value with another value in the RGB565 formatting system, and just like that, the pixel appears in the frame buffer. It's just that simple. But in reality, game developers don't want to be updating every single pixel, every single frame. That would just take forever. And even if the developers did spend all that time, it'd be more like an interactive movie or one of those like fancy PowerPoint games you might have seen people make. But just more work. So what do we need? We need lines. What better way to draw a line than just copying some old guy named Jack Bressenham? He's this really smart retired computer scientist who came up with just a bunch of algorithms back in the early 1960s, with his most well-known algorithm being called the Bressenham's line algorithm. It just uses a bunch of math that took me a really long time to understand because I failed calculus back in high school, and guess what? It uses calculus. Basically, it takes 2 points on the x and y axes, and then it just figures out which pixels between them need to change so that a line appears. I copied my implementation from a GitHub page, which I've linked down in the description. It's really handy. Most of his algorithms are just written in plain C, which I'm using for this project because all the other languages suck, except C++. He's cool, and I'll get to him next video. And you must be saying, Mr. Epic Dev, surely you can't just make 3D shapes in video games with just lines and pixels. And you'd be right. Here's your prize. Now, back to the topic. Shapes are not much harder than lines. There's really only two main shapes we need to create, and I'll talk about those in the next segment. As the title card shows, we need two main shapes. A rectangle for tile-based games, and triangles for 3D models. The first of the two is actually relatively simple. All I need to do is make a sadder version of the line function from earlier, except this one only makes horizontal lines. Then I just throw 40 of them on top of each other and boom! Rectangle! You could put your Ultra Marios and your Sonic the Echidnas on here and it'd be great. It'd be like you're on the Sega Entertainment System or whatever it's called. But now we need to pause, because this next shape, I'd call the Dark Souls of shapes. This is the shape that, not even joking, broke into my house, stole my air fryer, and beat me up. If it pointed even slightly off, it'll break your entire system. This is the triangle. Now, the triangle's a really scary shape because I don't know what I'm doing. And that's the hard bit. Usually what I do is I just give a bunch of numbers to OpenGL and it does it all for me. It's that simple. But I don't have that luxury just yet. So instead I've come up with a super simple workaround. I don't do it. And I just get ChatGPT to do it for me. And honestly, this works great. Because I'm lazy. And yes, the algorithm ChatGPT gave me eventually worked. It took like 12 iterations. But it's beautiful. And honestly, it could almost bring a tear to my eye. But I wouldn't say we're quite done yet. There's one more thing we need to do before I can start making some games on this thing. Out of everything we've spoken about in this video, of the shapes, the rectangles, the cartridges, this section is nowhere near as difficult as all those. It's just buttons. We all know buttons. We love buttons. Buttons are fun to press. They go beep and they go boop. And in code, they're also really simple to understand. It's just a bunch of variables that are either true or false. If a button is pressed, it's true. If the button is not pressed, well, it's false. That's all it is. And I made a really simple program with just that logic, like all of it in 1 or 2 minutes. And with that, I think everything's been covered in the video. In theory, I could just make a bunch of games now, but just ignore the fact I haven't implemented textures, audio, transitions, the actual hardware, just a bunch of other unimportant things. The system is basically complete. I just want to take a quick moment away from this video. I just want to say I was fully ready to end the video at this point, but all my applications have just been completely one-upped by one of my own stream moderators, who decided it would be a good idea to completely ruin the sanctity of the project by creating Rust bindings for the API. And then he created some really cool projects with it, so I just wanted to show them off. First, he made a RTX 5090 Cyberpunk DLSS 5 on Ultra HDR OLED Extreme Raycaster, and it's really cool. And after that, he ported an entire Chip 8 emulator to that, and it can even load the Chip 8 programs. It's not just the emulator. Like, look. Basically what I'm saying is he's a nerd, but there's a really good list of examples that show what the system is already capable of. And it's just going to keep getting better, so make sure you subscribe to catch the next part where I dive into the operating system, I rewrite half the stuff I've got now in C++, and I also just want to let you know I stream a couple times a week, and if you want to chat about the project, join the Discord, links in the description. Thank you for watching.